Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's presentation on normal distribution, Part 2. Let us recall the previous session. In the last session, we have discussed the introduction to normal distribution, the definition of normal distribution, and the standard normal variate given by z equal to x minus x bar by sigma, where this x is the normal variate and z is the standard normal variate. So, to find the probabilities in normal distribution, we convert x to z using this formula, and then standard normal distribution given by f of z. To find the probabilities, we use integral notation, since here the random variable is a continuous random variable and the normal distribution is a continuous normal distribution, and the curve, the graph of normal distribution is called the normal curve. And then we have discussed properties of normal distribution, and some important properties that we have discussed in the last session are: the total area under normal distribution is unity. That means integral from minus infinity to plus infinity f of z dz is equal to 1. And the normal curve is symmetric about y-axis, and it is bell-shaped curve. It is unimodal, that means the mean median mode coincides, and here the total area under the normal curve is equal to 1, which is the probability. The total probability is always unity. Since the curve is symmetric, the left side portion is equal to that of the right side. So that means the left side area from minus infinity to 0 is equal to 1 by 2, and the positive portion from 0 to infinity, that is also equal to 1 by 2. So it is divided into exactly 2 halves. Since the normal curve is symmetric, the normal distribution table was constructed only for positive values. And here some of the important properties are: the area from minus a to 0 f of z dz is equal to 0 to a f of z dz. That means the negative portion and corresponding positive portion are the same. So if you want to calculate from minus a to a f of z dz, this is equal to 2 times of 0 to a f of z dz. So it is enough to find the probability from 0 to a using the normal distribution table. In the table, the z values are given in the leftmost column along with the top row, and the entries are the probabilities or areas. These are the probabilities or areas. Now coming to the today's presentation, today we will discuss about the standard normal table, how the table was constructed and how to find the probabilities or areas using the standard normal table, and then we find the area or probability using standard normal table. Now the standard normal distribution table, as the standard normal curve is symmetric, the standard normal distribution table was constructed for positive values of z. Just now I told, since the negative portion is equal to corresponding positive portion, it is enough to calculate the area or probability from 0 to a instead of finding minus a to 0. And the table gives the areas or probabilities from 0 to some z value. So the table was constructed from 0 itself. So all the values are given from 0 to a given particular value of z, and 99.73% values are lies between minus 3 and plus 3. And in the table, the leftmost column along with the top row. So just now I told, the leftmost column and along with the top row gives the z values, and the entries are the probabilities. These are the probabilities, and the table is as shown in the figure. So here you see the Z values are given in the leftmost column. So these are the values along with the top row, and the entries are probabilities. So these are the probabilities. Now for example, if we want to find the probability from 0 to, so probability from 0 less than Z less than 0.93 for example. So all these probabilities or areas are calculated from 0 itself. So no need to check for 0. And here we need to calculate Z value that lies that is less than 0.93. So let us go for 0.9 value in the leftmost column. Here we have 0.9 value and 3. And this top row denotes the next decimal. So 0.93 means this column here. So 0.9 and 3. So the answer is 0.3238. That means 32.38 values are between 0 and 0.93. Similarly, if you want to calculate 1.28, probability from 0 to 1.28 or area from 0 to 1.28. So 1.2 is here, marked here, and 8, the next decimal corresponding to the top row, this, so this value 0.3997. So the area from 0 to 1.28 is 0.3997. So like this we calculate the values or the areas or probabilities using the standard normal table. Now let us find some probabilities or areas. So the first question, find the area capital A under the normal curve. So here area or probability both are one and the same. The standard normal distribution curve gives the areas or probabilities. The table gives the areas or probabilities. Now we need to find the area under the normal curve to the left of Z equal to minus 1.78. So to find the area, corresponding area, let us draw the rough sketch of the normal graph, normal curve. So this is Z, this is f of Z. Now Z value is given as minus 1.78. So that means it's a negative value. So this is 0, minus 1.78, let us consider here, minus 1.78. We need to calculate the area to the left of this value minus 1.78, left side region. So this is the required region to calculate. So now the area of this region. So probability of Z less than minus 1.78, that is given by from minus infinity, here minus infinity, to minus 1.78 f of Z dz, which is equal to, we cannot find this value directly from the table. The table gives all the areas from 0 to some value of Z. You can see here 0 to 1.28 is this value. Similarly 0 to, for example 0 to 0.74. So 0.7 and 4, this value is from 0 to that 0.74. So we cannot calculate this value directly from the table. So how can we find this? We know that this negative portion, this complete left side region is equal to 1 by 2. So let us use that minus infinity to 0 f of Z dz. From that region, if we subtract this region, that means from minus 1.78 to 0 f of Z dz, that gives the required region. And we know that this area is equal to 0.5 minus, from the properties of normal distribution, the area from minus 1.78 to 0 is equal to corresponding positive area. So 0 to 1.78 f of Z dz. Now 1.78, using the table, this is 1.7 and 8 means this column. So 1.78, 0.4625. So this is equal to 0.5 minus 0.4625 from the normal distribution table. So this gives 0.0375. So this is the area to the left of Z equal to minus 1.78. Similarly, to the left of Z equal to 0.56, the second problem. Again draw the rough sketch. Again draw the rough sketch of the normal curve and denote the point. So this is 0, Z, f of Z, So it's a positive value 0.56. To the left of z equal to 0.56 means this is the region to be considered, and we need to calculate the area of this region. And here we can clearly observe that from minus infinity to 0 and then 0 to infinity, this is the total area, and our required region is more than that half negative portion. So this is probability of z less than 0.56 is equal to minus infinity to 0.56 f of z dz. We know that between negative and positive values there is 0. In between these two we have 0, f of z dz plus 0 to 0.56 f of z dz. And we know that this negative portion is equal to 0.5 plus 0.56, 0 to 0.56. We need to calculate this area using the standard normal table. Let us go back to the table. 0.56, this is 0.5 and 6. So 0.2123. From the normal distribution table, the area from 0 to 0.56 is 0.2123. So 0.2123. Hence the final answer is 0.7123. This is the area to the left of z equal to 0.56. So that implies we can identify observe one point from these two problems, that if you are finding the area left of a positive value, then it will be more than 0.5. If you are calculating the area to the left of a negative value, that will be less than 0.5. Now coming to this right side area, to the right of z equal to minus 1.45. That means probability of z greater than minus 1.45. So if you draw the rough sketch, it is a negative value. So here minus 1.45, 0, z, f of z. Now we need to calculate the area to the right side of this negative value. So if the value is negative, the area to the right of this negative value will be more than 0.5, because here from this point to this point the area is half, and in addition to this we need to calculate this area. So this is given by minus 1.45 to infinity f of z dz, and which is minus 1.45 to 0 plus 0 to infinity f of z dz. So between negative and positive values there exists 0, and here we know that this value is equal to 0.5 and the negative portion is equal to corresponding positive portion. So minus 1.45 to 0 is equal to 1.45. The area from minus 1.45 to 0 is equal to the area from 0 to 1.45, and now we can calculate this area using the table, standard normal table. Now using the standard normal table, 0 to 1.45. So 1.4, this is the value, 5 corresponding to fifth. So 0.4265. 0.4265 plus 0.5. So the answer is 0.9265. So 92.65% values lies to the right side of z equal to minus 1.45. So like this we can find the area or probability using the normal distribution table. Similarly, let us discuss some more problems. The next one, greater than or equal to 2.16. So probability of z greater than or equal to 2.16. That means from 2.16 to infinity f of z dz. So if you identify this, the region which is required to calculate means the left side region or right side region, negative portion or positive portion, then we can calculate the area using the standard normal table. To identify that region, let us draw the rough sketch of the normal curve, 0, z, f of z, and this is the positive value 2.16, and if the value is positive and it is required to calculate the right side region to that positive value, obviously the area will be less than 0.5, because we know that this total positive portion is equal to 1/2. So we cannot calculate the area from 2.16 to infinity using the standard normal table. the standard normal table gives the value only from 0 to some z. So that's why let us write this interval as 0 to infinity f of z dz. From that subtract we know that this total region is equal to 1 by 2. From this, if you subtract this value 0 to 2.16, that gives the remaining portion. So 0 to 2.16 f of z dz, and we know that the half of the region is 0.5, and now we can calculate this area from the normal distribution table. And from the standard normal distribution table, the area from 0 to 2.16 is 0.4846, and hence the final answer is 0.0154. Now coming to the next one, to the left of z equal to minus 2.52, let us draw the graph. This is z, f of z, negative value minus 2.52. So to the left of this means left side region. To the right of z equal to 1.83. So let us consider positive point here, 1.83. To the right of this. So we need to calculate this area plus this area. For example, alpha 1, alpha 2. So the final answer is alpha 1 plus alpha 2. But using the standard normal table, we cannot find this total area. What we can do? We can calculate the area from this negative 2.52 to 0 and 0 to 1.83. We can calculate these two. For example, these two are A and B, and we know that the total area under the normal curve is 1. So this alpha 1 plus alpha 2, the sum of this left side region and right side region is equal to 1 minus sum of these two, A plus B. So the final answer is the area from minus 2.52 to 0 f of z dz plus area from 0 to 1.83 f of z dz, and the negative portion is equal to corresponding positive portion 0 to 2.52 plus 0 to 1.83. So we can find these two areas using the standard normal curve, and the value is given by area from 0 to 2.4252 is 0.4291 plus, so the area from 0 to 2.52 is 0.4941 plus area from 0 to 1.83, 1.8 and 3, 0.4664, 0.4664. So here this is A plus B. So the final answer is, so the total value is 0.9605, and we need to calculate the area from left to z equal to minus 2.52 and right to z equal to 1.83. Hence the final answer is 1 minus this 0.9605, which is 0.0395. So this is the area left side to minus 2.52 and right side to 1.83. Similarly, we can calculate the area corresponding to this probability of minus 0.8 less than or equal to z less than or equal to 1.53. Here the area or probability both are one and the same. So negative to positive value, minus 0.8 to 1.53. So between these two we have 0 and 0 to 1.53. So this minus 0.8 to 0 is equal to 0 to 0.8 plus 0 to 1.53. These two values can be calculated using the standard normal distribution table, and hence the final answer is 0.7251. So like this we can calculate the areas under the standard normal curve. Now similarly, these problems are given for practice. You just pause the video and now you try to calculate the area from probability corresponding to z greater than or equal to minus 1.64. So that means this is greater than or equal to minus 1.64, means minus 1.64 to infinity f of z dz. So draw the graph and denote the points, negative value here, and we need to calculate this right side region. Obviously it will be greater than 0.5, and you try to calculate this value using the standard normal table. So, these problems are given as practice. Similarly, here z less than or equal to 1, that means integral from minus infinity to 1 f of z dz. So, draw the graph, denote the point less than. So, this left side region, obviously it will be equal greater than 0.5. Similarly, the value that lies between these two, this is equal to 2 into probability of 0 to 1.96, since the corresponding negative value to corresponding positive value. So, 2 times of 0 to 1.96 f of z dz. This value you can find using the standard normal table. So, these 3 problems are given for practice. And so, coming to the today's session, today we have discussed about the standard normal distribution table and how the table was constructed and how we find the probabilities, and this table gives the area from 0 to some given z value. All the values are calculated from 0. So, simply we need to concentrate on this z. And in the next session, we solve some problems on normal distribution. So, to use the standard normal distribution table, we need to find the value of z, and this standard normal variate is given by x minus x bar by sigma. So, if x values are given, we need to convert them to z using this formula, and then we find the area that z lies between two values, z1 and z2. So, in the next session, we solve some problems on normal distribution table. So, thank you very much, and we will meet in the next session.